Welcome to the Learning Video Series Extending Map Suite. This is Lesson 3, Exploring Layers. And what we're going to do is we're going to explore what's possible by inheriting from Layer. My name is David Rehagen. It's my pleasure to present to you today. The agenda. We're first going to start by answering the following questions. What is the difference between a layer and an overlay? This is a really common question that we're going to answer. What does the layer inheritance hierarchy look like? Why would I inherit from layer? And finally, what is required for a custom layer? We're then going to go and look at some code, and we're going to view a number of samples. The first one being a multi-geo raster layer. The second is a watermark adornment layer. The next one is a MiniMap adornment layer. And finally, we have the MapShapes layer. And I think you're going to find the MapShapes one particularly interesting. And then to follow up, we're going to answer any questions you guys have. Of course, you can always ask questions during the webinar by typing it into the GoToMeeting interface. So what is the difference between layer and overlays? We'll start with layer. A layer is a member of the core namespace, and because of that, it's intended to be used across all of the different Map Suite products. So you can use a layer in the Web Edition, in the Silverlight Edition, and it'll work in any of the different products. It's also intended to typically be linked to one particular type of data. So if you have some data on roads, then that would typically be a layer. And if you also had some data on parks, that would be a separate layer. And you wouldn't normally see something like a layer representing roads and parks together. And this is kind of a contrast, in contrast to the overlay. An overlay is meant to be specific to a particular product. So the overlay for the desktop edition is going to be potentially different than an overlay for the web edition. And the same thing is going to be true for the Silverlight edition, etc. And the overlays are designed to take advantage of the platform capabilities. So in the desktop, the overlay has different methods because it wants to take advantage of knowing that we're on a client, where an overlay on the web might have some different methods because there's different capabilities in the web environment. You can also use overlays to aggregate layers together. An example of this may be that you have 50 layers that make up, let's say, the world map kit that displays data for the entire world. Well, you might want to treat all of those different layers as one kind of logical unit. And so you would put all of those layers into an overlay, and you can turn that overlay on or off. There's also capabilities in different platforms to do caching. So you can say, well, I don't want to cache every single layer of the world map kit as far as tiling, but I want the caching to happen on an aggregate of all those layers. So that's another way that overlays can be helpful. And overlays are also used in our different products to facilitate rapid drawing and refreshing of layers. And the rapid drawing kind of alludes to the caching, and we've done quite a bit of work on caching of overlays for the desktop and the web, but also you can also refresh by overlay. So if you're in the desktop edition and you have two different overlays, let's say one overlay is represented by the world map kit, and you have another overlay that might be cars that you're tracking that are moving around, then what you can do with overlays is that the platform knows a little bit more about how it can do certain amounts of caching, and that you can say that I want to refresh just the cars and leave all of the static kind of data like in the world map kit alone, so we don't have to re-render any of that. And so the overlays can be used to facilitate that kind of rapid refreshing. And you can put a bunch of different layers that are very dynamic together in an overlay, and you can refresh all of them at once. So just at a high level, you can think of layer as something that's really tied to a particular kind of data. Like if you have some custom data that's represents roads, then you want to tie that to a layer, especially if you want to use that data in a bunch of different products. And you can think of an overlay as something that more aggregates data. It's more specific to a particular product that we have and is used to kind of get the most out of that platform. What does the layer inheritance hierarchy look like? So we're going to start with layer, and this is what all the other types of layers are inherited from. It has the fewest number of overload members. Of course, since it's kind of the base, it has the fewest number. It provides the least amount of default functionality. It's kind of a blank canvas, so to speak. But it provides the highest degree of customization because there's not really much there, so you can build anything you want on top of it. It's that blank canvas. And because of that, it's very quick to get things up and running, especially if you have simple scenarios or you don't want to have the baggage of some of the other layers. The inherited classes that we've built on top of it are the adornment layer, feature layer, and the raster layer, and we'll go into those one by one here in the next few slides. So we're going to talk about the adornment layer and feature layer now. The adornment layer was designed to draw things in screen coordinates, and there's often the case where there's things that you want to draw on the map that aren't in geographic coordinates, like a north-facing arrow or a scale bar or a legend. And so we've decided to come up with this concept of an adornment layer, and it's very similar to a regular layer, except that you typically do drawing in screen coordinates. And what we've done is in various products we've implemented adornment layers inside of adornment overlays in such a way that when you do panning, typically things that are in adornment layers, you don't want them to pan. So for example, if you have a north-facing arrow and you have that in the bottom left-hand corner of your screen, when you go to pan the map and you click and move, you don't want to see that arrow moving and then kind of jumping back to the lower left, because that arrow isn't in geographic coordinates, and when you're panning, you're changing the geographic extent of what you're looking at, and you don't want those things to move. So we've created the adornment layers for that. And like I said before, they're very similar to layer, and there's only a few small things that we added to it. So in this particular presentation, we're going to show you things that inherit from layer and things that inherit from adornment layer because they're so similar. We're going to cover them both in this one video. The feature layer is what we've actually covered this in our first extending map suite video, and I highly recommend that if you're watching this video to try to create new kinds of layers because you have some vector data that is in a proprietary format or it's in a particular database that we don't support, then I really recommend that you go back and watch that video first, because that video is really focuses in on dealing with vector data, and there's a number of different pieces of functionality that we've implemented into the feature layer that helps you out, such as spatial querying, editing, projection, where if you inherit from the feature layer and you do just a little bit more work, we can give you a lot of additional functionality, and it's going to make it really easy for you to implement your vector data. So I strongly recommend watching that video if you haven't already seen it. And as I said, it's created to represent vector data, and it's created to provide all the different functionality that you typically want to have with vector data. And the last one is the raster layer. And the raster layer was designed for drawing raster imagery, and we've implemented a number of different raster layers that support file formats such as Mr. SID, ECW, GeoTIFF, etc. And it was designed to be drawing system neutral, meaning that it didn't rely on the fact that we were using WPF or that we were using WinForms or a PDF drawing system or anything else. And because of that, we have the concept of a geo image that is kind of encapsulated in these raster layers, and it uses a PNG stream, and we thought that PNGs were fairly standard. They support transparency well, and so we use that as kind of a transport. But beware, what we've been noticing is that with heavy use of raster imagery, if you have a lot of different layers of raster data drawing, then the overhead of actually getting the data from its original data source, let's say ECW, then converting that and compressing it into a PNG stream, then we move that geo image compressed stream into the geo canvas, where we have to end up turning it back into some native form, like a bitmap to be drawn in GDI Plus or in WPF, that has a performance hit on it. And we're actually looking into ways that we can kind of sidestep that performance hit by getting around the geo image, but still trying to remain as drawing system neutral as possible. So that's something that we're actively working on, and probably some of you have run into it if you have applications that, let's say, load 30 different GeoTIFFs or 30 different ECW images. And the raster layer itself will be a topic of an upcoming video because there's a lot of different methods and properties and things that go into the raster layer. So we'll have a separate video for that. So why inherit from layer? There's a number of different reasons, and we'll start from a technical standpoint. One important benefit is that it provides the least number of overloads and dependencies. So if you're trying to do something that's very straightforward and you don't want to have the overhead of supporting spatial queries or supporting drawing image neutrality or having to support projection or any of these things, then layer is that blank canvas where there's very little that you have to do. Of course, there's little functionality that comes along with it, but if you're doing something that is very specific and you know exactly what you want to do, then layer might be a good candidate for you. And it allows you to really quickly get up and running. So you may have, let's say, some proprietary data that you know eventually you want to have in a feature layer with a feature source. But you want to get up and running really quickly. It's not necessarily a bad idea to first try to get your data displaying with a layer and then back it into the little bit more complicated feature layer. So that's something you can consider technically. From a requirement standpoint, layers can aggregate different kinds of data that we have broken out. So for example, we have a feature layer and we have a raster layer, but you may have a requirement where your layer needs to display raster and feature data together. So that would be a kind of a requirement standpoint, and I'm not sure why you would want to do that, but you never know. I'm surprised every day by what people need to do. The second is that you might want to get the best possible speed by avoiding some of the overhead of other layers. For example, feature layer is really great because it offers a lot of functionality that's relatively free for you, such as spatial querying, live editing, projection support, some caching, and things like that. But there is some overhead. It's kind of a pay for play. If you want a little bit more functionality, you have to pay a little bit more in performance. Now, we've tried to keep that performance penalty as little as possible, and I think for all of the different benefits that you receive, if you're integrating vector data, I strongly recommend you use a feature layer, but you might not want any of that stuff, and you might want to, get one more millisecond of performance out of the thing, and so the layer is going to be your best bet because it's at the lowest level of the system, and there's very little in between you and the drawing system at that point. You might need to have, or you might have special requirements like map shapes. We're going to be getting into a little bit more about what map shapes are a little bit later, but just as a prelude to that, map shapes are kind of this concept that you have features where they are almost layers unto themselves. So you might have a car, a plane, and a factory, and maybe they don't really share very many things in common. They have different styles, they have different zoom levels, and so what map shapes allow you to do is they allow you to take those couple of different features and kind of create little mini layers unto themselves that are associated with just that feature. If you wanted to do the same kind of functionality with our layer system, you'd have to have a different layer for each one of those map shapes. And so we have a little sample. And a lot of people really liked the map shapes in the 2.0 product. However, what we quickly found out was that there was a common pattern that was arising where people would start out and they would say, wow, map shapes are really easy. I'm going to put my 50 cars that I'm tracking in map shapes, and they find out that it's a little bit slow because each one is kind of its own little castle. There's a lot of overhead in dealing with it. So then they say, well, what I really want to do is I want to take all of these cars and put them into one common source, and then I want to kind of change the styles based on some attributes of those cars. And so they quickly end up moving away from map shapes and going into a model like what we've kind of set up as the default model in 3.0, where you use an in-memory feature layer so that you can load up all your cars and then you just set different styles. But there's still some cases where maps shapes might be the best way to go if you have few features and you don't mind a little bit of the overhead. The other requirement is that you may want to produce something that's simple and straightforward, and we kind of already talked about that. And if it's simple, then the layer is the best bet because it has the least overhead and there's very few things that you have to implement. The other thing that you might want to do is you may want to draw in screen coordinates. And of course, feature layer is really designed for features, and features are in geographic coordinate systems. So let's say that you wanted to do something like watermarking, which is a little sample that we'll show you. Well, you could create watermarks in geographic coordinates, and then every time the user pans, you could calculate between screen and world coordinates, and you could move these things. But it's a lot easier if you just draw in screen coordinates, because then your watermarks will be fixed, and it'll be a lot more easier to implement. So for that kind of stuff, we recommend using layer. Otherwise, you're going to be fighting against the feature layer. So what is required for a custom layer? As far as required overloads, there's only one, which is DrawCore, and this is where all the drawing takes place. If you watch the video on the feature layer, DrawCore would pass in a GeoCanvas and some features to draw along with some labeling information. Well, in a layer, it's even more simple because the DrawCore just passes in a GeoCanvas and also some labeling stuff. So if you do labeling inside your layer, you can have that labeling kind of integrate with our overall labeling strategy. But typically, the only thing that you're going to get that's going to be useful to you is the GeoCanvas. And so it's basically saying, hey, I have this layer, I'm ready to draw, here's a GeoCanvas, draw on the GeoCanvas whatever your data represents. So it's very, very simple. On the recommended overload side, there's just a couple of them. The first one is has bounding box core, and that one is matched up with the get bounding box core. And this one just indicates if your layer that you're creating has some concept of a bounding box, or there's some way that you can get the bounding box of all the shapes, then it's useful to users to have that. And the has bounding box core is a get property that you override, and you would right now by default it's false, and you would override it and you would pass back true. And then you need to override the get bounding box core and have it return that bounding box. Now, the default implementation of get bounding box core is to raise an exception. So you always want to check to see if you're ever going to call this, you want to check the property first, has bounding box core, before you try to call the get bounding box for the particular layer. So those are just if you know it. If you don't know, like for example, if you're creating a MiniMap layer or a Watermark layer where there really isn't the concept of a bounding box for those kind of things, or you have a north-facing arrow, there's no concept of a bounding box there, then you can just leave these alone and they'll return back false, and it'll let users know that there is no bounding box for this. The other two are kind of related as well, and they're open core and closed core. And the open core is to initialize expensive resources for the layer that you're going to use, and the closed core is really to release those expensive resources. And this is typically used in scenarios where, let's say you might go to the database, and the open core you might create these connections, and the closed core you might close them. The other scenario is where we want to do serialization. So before you serialize a particular object, we typically recommend you call the closed core on it. So if there's some different, maybe some private members that don't serialize, then inside the closed core you can free up those resources, and you can set those objects equal to null. And then since they're equal to null, even though the type isn't serializable, the entire class will serialize just fine. So you'll want to do that. Now, one thing that's kind of interesting is that depending on the different platform or the particular product, whether it's the web or the desktop or the Silverlight, the open and close cores get called kind of differently. For example, in the web edition, the open and close are going to be called every time we do a drawing or every time we get a web request. And the reason is because, well, you have a client that's disconnected from your server, and you never know when that client is going to make its last request. So to conserve resources, we want to close those resources between web requests. Now on the flip side, like let's say for example the desktop edition, when we go to draw, we're going to open these layers and we're going to keep them open because we can control the kind of the life cycle. We know that when a user clicks the close button that we'll get an event for that, and we know that. So things in the desktop edition might remain open for a really long time. And it's a good thing because we experience, the performance benefits of keeping these things open and not having to close them or reopen them. Now, of course, knowing that the web is going to try to open and close these things, you can kind of bypass that a little bit by overriding the open and the close core. And instead of obviously the web is going to call the close core whenever it's done with a particular request. But that doesn't mean that you have to free up those resources. You can keep those resources open and you can get some of the speed benefits. However, you have to understand that, with that blessing comes the curse of you have to manage those resources yourself, and we're not going to be doing that for you. So just something to be aware in the open and close core when you're thinking about implementing them in different products like the web or the desktop. So the sample code overview, we're going to be dealing with 4 different samples today. The first one is a multi-geo raster layer, and it's going to show you how we can aggregate a group of raster images into one layer. And we did this because there was a user that said, well, I have a directory of hundreds or thousands of GeoTIFF images, and I'm afraid of creating a layer for each one of those because I'm just afraid of when I call the open core, is it going to initialize all these different files? And there may be of the 1,000, a typical scenario, the user might only see 10 of them or 20 of them. And so what we're doing in this particular sample is that we're going to create a layer that's going to load these raster images kind of on demand based on the current extent that gets passed into it. The second sample shows how we can do some drawing of watermarks on the map. And this one is really handy if, when you're building your application, if you want to send out demos to various clients and you want to have some watermarking on there. And it's a good example of how you can use the adornment layer and draw on screen coordinates, because obviously you don't necessarily want the watermarks to move around. They're not geographic objects, they're things that you want to draw in screen coordinates. The next one is the MiniMap adornment layer, and this just really shows how easy it is to create a simple MiniMap layer where, so you can provide a reference to your users, like when they're zoomed in really close, kind of give them a reference of where they are, in the world. And you'll see that this is fairly easy, and in fact we're going to be coming out with an official supported MiniMap not too long from now. But one of the interesting things about minimaps is that in our research there's no perfect minimap, and a lot of times it's really up to the specific application of how you want to display that minimap. So I'd recommend that if it's something that you want to do, that you maybe take this sample and build yourself so you can get exactly what you want. And the last one, but not least, is an example of MapShape layer, where we kind of alluded to it before, where you can have a layer that has different features, but each feature has its own set of zoom levels, its own set of styles. It renders separately, and it's really powerful if you have, let's say, a handful, 10, 20, 30 items that are just vastly different from each other, but they don't really warrant creating their own layer for each particular item. So we'll go into that. Alright, well let's take a look at some code. So the rest of this we'll be doing in Visual Studio. You can find all the code that we reviewed today in a zip file accompanying the video on ThinkGeo.com, and I think more specifically in the developer blog area in the discussion forum. To compile the code, it's going to require that you have installed a full or evaluation edition of any of the MapSuite 3.0 products. You'll need to add a reference to the MapSuite core DLL. Otherwise, it's not going to compile. And actually, we might even be shipping an evaluation of the MapSuite core DLL in there. But I think you need to have it installed to get the registration stuff sorted out correctly. Without further ado, well, let's go look at some code. Here we are in Visual Studio, and we have open the samples that accompany this video. And it's set up like this. We have a test form, as in all of our samples, and then we have these various classes, which are the sample layers themselves. What we're going to do is we're going to first take a look at the sample framework and start with the first sample. All right. So the first one we're going to look at is the MultiGeo Raster Layer, and what we've done is we've created a whole bunch of tiles, actually I think 106 tiles or so, off of our world map kit. And what we're going to do is we're going to go ahead and get to a zoom level where it looks good, and we're going to display that. And actually, even just within this particular area, there's probably 5 or 6 different tiles that are being loaded, and we can pan around, across the entire world. And what it's doing is it's dynamically, based on the extent, loading just the images that we need. So instead of having 106 layers, we're just having one layer, and it's going to go ahead and load these in on demand. Alright, well let's take a look at the code in the test form to see how this works. So here's the test form load. This code here just sets up our background. So we just have the world layer. And what's more interesting is when we click the MultiGeo Raster button click. And we're going to go ahead and clear out all the layers. Then we're going to build a reference file, and in the MultiGeo Raster Layer, the way that it works is that, let's say that you have 100 TIFF files or something in a particular directory. You call this build reference file, and you give it the reference file you want to create and the path where it's going to create it from, and we'll actually go through, look at each particular TIFF or ECW or Mr. SID file, and we'll build up a reference text file that has what the extent is and where the image itself is at. And then when we actually load up the layer, we pass in that reference file, and you're gonna see that it's gonna load that reference file into memory, load it into a spatial index. So when a new extent comes in every time we draw, we can really quickly find out, oh, for this particular extent, we need images 5, 7, and 21. And then we add it to the layers, and then we draw. So using the layer is really simple. Now actually, let's take a look at the code inside of it. Okay, it's just some important stuff. Internally, we're actually building a R-tree index, and to do that, we need you to reference the Net Topology Suite and Geo API in your project. They are already dependencies of MapSuite, so you just need to make sure that you reference them in the project. This is just a general description about what it does. I've already kind of discussed that. The reference file format, you have the upper left X, lower right Y, upper left Y, lower right Y, and then the path. And here's a little sample of what that text file looked like. You'll just have one row for every image. Here we have some constructors. In a nutshell, we have a constructor that allows you to pass in the reference file. We optionally have an upper and a lower scale, so you can choose to not show the images once you get below a certain scale or you get above a certain scale. And then we just have the properties that support those constructors. And it's always important, for good form to have a property for every different constructor parameter that you have, and make sure that the parameter name of the constructor matches the property name, and that you always have a constructor that takes no parameters, and that you kind of chain them. And then we have the open core. And remember, the open core is where you initialize things. And in this particular case, what we're doing is that we're going to try to open this reference file, and we check first to see if it exists, and if it doesn't, we're going to throw an exception saying that we couldn't find it. If it does exist, we're going to read all the lines, and we're going to build this R tree, and we're going to basically load the R tree up. And there's a little bit of code in here because the envelope for the Net Topology Suite is a little bit different than our rectangle, but it's relatively easy in a few lines of code. So this kind of sets the stage and gets our index ready to go. And in the closed core, we set the spatial index to null, so we get rid of that data. And then here in the DrawCore is kind of where the magic happens. And what we do here is we first get the scale. And we pass in the canvas's current world extent along with the canvas width and map unit. And we're going to do our verification here on whether or not we're in, between the lower scale and the upper scale. And if we are, then we're going to query that spatial index, and it's going to pass back an array of the different raster images that are currently within the extent. Then for each one, we're going to loop through, and we're going to create a layer for it. We're going to open the layer, we're going to draw, and we're going to close. Now, of course, since we're opening and closing, there's a little bit of overhead if a user pans around and he's seeing the same images over and over. So one way that you could enhance this sample is to create some sort of dictionary or collection of these raster layers that have already been opened. And so you could check, once it's been opened, store it in the dictionary, and then wait. And if it gets requested again, you can check the dictionary, and if it is there, then go ahead and reuse it, and you should be able to eke some more performance out of that. You just need to make sure that on the close that you go through that dictionary and you close all the raster layers and then clear them out. The next one is the has bounding box, and in this case we say true because we know what the bounding box is because we have that file that says what all the extents of all the images are. So we're going to say true, and then in the get bounding box we're going to return the bounding box, which is actually a member variable that we set, I think, when we did the open core. So yeah, what we did in here, and I forgot to mention, is in the open core, once we go and we build up our spatial index, then we get the bounding box. We pass in all the bounding boxes that we did, and there's a little method off of the extend helper called get bounding boxes of items, and that returns back that bounding box. And really, that's pretty much it for the actual implementation of it. I did include a little function that actually builds up the reference file, and so here you pass in the path of the new reference file along with the file name that you want it, and then you pass in a path of raster files, and it's going to go through here, look for anything that's JPEG. Of course, you could enhance this to use PNG or TIFF or Mr. Sid or whatever you want. And then it uses a stream reader. We loop through all the files, and then we use a stream reader to actually write out the information in there. So that pretty much is it for the multi-geo raster layer. But I hope that what you can see is how flexible the layer is, and how you can take something like the raster layers and you can aggregate them all up into a custom one. So let's go ahead and take a look at the next sample. We'll run this again. The next one is the watermark layer, and if we click that, you'll see we have watermarks, and you can pan around and you notice that the watermarks don't move, and you can zoom in and zoom out, and it's drawing these watermarks. So let's take a look at the code. in the test form to see how we set that up. And it is right down here. We go ahead and clear the layers again, kind of setting ourselves up for the new test. We add the world layer because that's going to be our backdrop. Next, we create the watermark layer, and it's fairly simple. It's a watermark adornment layer. We add it to the map engine, and really that's it. Now I think the watermark itself has some additional properties to it, and we'll see when we get into the code. So here's the watermark adornment layer, and there's our default constructor. We have the watermark text. It looks like we have an optional constructor as well where you can pass in what the watermark string is, and it just sets that little member variable. And we have a property that allows you to set it as well. And as you can see, there's really not that much code here. In the DrawCore, what we're doing is that we're going to go ahead and create a font that represents, how we want the watermark to draw. That font could have just as easily been a property as well that allows you to change it. The brush is, how we draw the font. That could be a property as well if we wanted to make it even more flexible, along with the color. We could also make this, semi-transparent, etc. We have the interval, so I guess this is how many pixels, every so many pixels we're going to draw this watermark, and so we just want to make sure that we don't draw it, or if we draw it only once, if the canvas width is greater than the interval. And if it's less than that, then we're going to go ahead and loop through, and basically this logic just make sure that we draw a watermark every 100 pixels, on the horizontal and on the vertical axis. And what it's doing inside of here is actually creating a text path. And the text path just has the screen points of where all these things are supposed to draw. So it builds up this text path in here, and then when it calls our canvas draw text, it provides the watermark, the font, the brush, that text path, and then the drawing level that it draws on, and we're done. So that's again shows a really small amount of code. It's pretty powerful, and it's a perfect example of what you can use layer, or more specifically adornment layer, for. So let's go ahead and run the next one. So the next one is the MiniMap layer, and as you can see, there's a little mini map down here. Let's actually zoom in a bit. This is a pretty common piece of functionality on maps, so I can see, if I go ahead and I zoom into Florida, I can see that I'm actually zoomed into Florida now. It might be hard to tell from this view, but from here it's pretty obvious, and I'm showing a little rectangle for where the current extent is located at. And you notice that it gets updated every time I move around. So let's see how this actually gets set up in our test form. Okay, so here's the MiniMap layer. We're going to head and clear out the other layers. We're going to set it up with the world layer as our background. We're going to create our MiniMap layer. We're going to set its location, because adornments have locations. So I could set this to the upper right, or the lower left, or the lower right, or pretty much anywhere on the screen that I'd like. And then I'm going to add some background layers, and also I'm going to loop through actually all the layers that we loaded and load those into the mini-map. So here I'm setting up a little background, and then I'm going to loop through all the map engine static layers. And in our case, there's only one, which is the world, but imagine if you had 2 or 3 different layers. You could load all those in the mini-map, or kind of more importantly, you might only want one layer in the mini-map. You could have, let's say, the world layer, and then on top of the world layer you have the cities, the major, the world capitals. You could have some other data, but for the mini-map itself, you might only just want the world layer. So we load those up in the MiniMap layers, and then you add the MiniMap layer, and you draw. So it's really simple to set up. And let's look at the code behind it, and you'll be surprised kind of how easy this is. So here we have that collection of layers that we loaded up, so it can be one or it can be all your layers. We have a height and a width of how big we want the mini-map, and we have a number of constructors that allows you to pass in some layers or height and a width, or the layers with height and width. And then we have the properties to kind of mimic or shadow the constructor parameters that we have. And this is it in the DrawCore. I mean, this is it for the entire mini-map. What we're going to do is we're going to create a geo image, and we're going to basically get the drawing extent based on the canvas. We're going to scale that up, because what we want to do is we want to see something that's that's at a higher scale, so we scale that up. We're going to create a GDI plus geo canvas. We're going to say begin drawing. We're going to pass in that geo image that we created along with the extent, and we're going to loop through each layer, and we're going to call the draw. So it's going to go ahead and draw, and so then basically this geo image is going to have the little mini map area. So we need to still take that mini map and we need to actually draw it to the screen. And so we're going to, let's see, we're going to do that here. Oh, actually, here what we're doing is we're doing a draw area, and that's going to put the border around the mini map, because you noticed, or you might not have noticed, but there's a little border around it that's gray. And so here we're actually drawing that gray border, and then we're going to end the drawing on our little mini map canvas. We're going to get the drawing location from the adornment layer itself. And then really the part that puts the little mini map image that we just created on the main map is this one line of code here, which is canvas.draw screen image without scaling. We pass in the mini map and we pass in the drawing location. And that's it. So let's take a look at that again, because I think that's kind of neat that we can do all that in just a couple lines of code. And of course, you could do all kinds of enhancements with this. For example, the size of this mini map is actually a scaled up version of what's in your current extent. But you could have the concept of a floor, where, let's say for example, no matter how far I zoom in, once I get to X particular scale, let's say this particular scale, then no matter how much I zoom in, the scale here doesn't change. And so that's definitely possible. All right, so now we can look at the last sample, which is the MapShapes layer. And let's go ahead and take a look at what that looks like. And what you'll see here is that we have a plane, we have a line, we have an area, and we have an icon. And what these are kind of supposed to represent is that they're single features, but they're rendered very differently. Some are rendered as a line style, some are rendered as an area style, some are rendered as an icon, and they don't have very much in common. So those make it perfect candidate for a map shape, and there's very few of them as well. So let's see what this looks like. And if you can remember that map shapes are kind of layers unto themselves. They're a feature that has all the capabilities of a layer. And so you'll kind of see as we set the code up for them that almost all the code that you have to write for a layer, you have to write for each individual map shape. And here it is. So we're going to go ahead and clear out all the layers, add the world layer, and then we're going to create our map shape layer, but we need to also create our map shapes. So for map shape 1, we're going to create a new feature at this particular coordinate, where you notice that each map shape has its own set of zoom levels. That means it can have its own styling. So this particular one is going to load a geo image. We're going to go ahead and add that map shape then to our map shapes layer. We're going to set up map shape number 2. It also has an icon, but number 3 is a little bit different. Number 3, we're actually going to do a world layer query, and that's how we get that polygon of Australia. and we're going to load that as a map shape as well, but we're going to use an area style for it. And we're also going to have the last one, which is just a line, and load that up. And then we take the map shape layer that we just created and we add it to the map engine. So, as you can see, each map shape is kind of, it has all the kind of trappings of a layer, but it's handled in one layer. So let's take a look at that. So here's the map shape layer. It has default constructor. It also, let's see, actually it's the only constructor, and it also has a collection of map shapes. And in the DrawCore, this is really simple, because what we're going to do is we're going to loop through all of these map shapes, and for each map shape we're going to call the zoom levels.getZoomLevel for drawing, because what we're going to see is that inside of each map shape we've implemented zoom level. Well, zoom levels has a whole bunch of helper functions that are going to help us in the drawing. And so we're going to call the zoom level.getZoomLevel for drawing. That's going to return back the zoom level that we need to draw. If there's not one returned, then we just skip over it, which means that we're outside of the zoom levels that we need for drawing. But if we are in a particular zoom level that's supposed to draw, then we're going to check to see if the canvas, if the extent that we're in, if it intersects the feature's bounding box. So here we need to actually go into the map shapes feature and get its bounding box. Now, this could be a little bit slow. It probably would be better to actually implement on the map shape itself a bounding box that could cache it, because what's going to happen is that if these are complicated features, then every time we go to draw, we're actually recalculating the bounding box over and over again. But of course that adds a little more complexity, because if you change the feature, you need to know to recache that bounding box. We could not only store the bounding box as a property itself, we could also borrow from one of the other examples, and we could create an R-tree spatial index for it. So as you add map shapes, they would be added into the R-tree spatial index. So that's another way we could speed this up. And then based on the current zoom level, if it does intersect, which means the map shape is within the current extent, then we call the current zoom levels draw, and we pass in the canvas that we have. We pass in a new feature array that just has the one single map shape feature, and we pass in the other collections that are required, and that's it. So if we look, now let's actually look at the map shape itself. And the map shape itself is pretty simple. It has a constructor that takes the default one, then it has one that takes feature. So that can be your point, your area, or your line, or what have you. It also has the property for it, and it has a zoom level set. And the great thing about the 3.0 architecture is that so many of the pieces that we use to create, let's say, a feature layer or a raster layer, those are all pieces that you can reuse. So in this particular case, we took this whole big block of functionality called zoom level set, which includes the 18 to 20 zoom levels plus all the default area styles, the default line styles, all that kind of functionality, and we've just bolted it on this map shape. And you saw from back here, how easy it is to call, because all of our logic from here on down is encapsulated in that zoom level. So it just makes it really easy to kind of mimic the functionality that we already have, just in a slightly different way by reusing a lot of the pieces that we have. So I think that wraps it up then for the code part of things, and we'll get back to the presentation. Well, thanks for watching, and for more samples and videos, visit the developers blog in our discussion forums. You'll find that we post very frequently to there, and there's a lot of great information. Whenever we have a user that makes a request to some piece of functionality we don't have, if we build up a code sample of a new type of layer or a new type of style, we'll typically kind of clean that up, and we'll post that to the developers blog area. So definitely bookmark that thing so you can get emails whenever it changes. And I think we'll be opening the floor up for questions now. Thanks.